hold a piece of light in your hand, what would you be holding? The answer is both simple and deeply weird. The smallest possible packet of light is a particle called a photon. You can think of a photon as a single, indivisible piece of light. It has no mass, no electric charge. It always travels at the speed of light. It's a pure bundle of energy. The color of the light you see is determined by the energy of its photons. A photon of blue light, for instance, carries more energy than a photon of red light. Now, here's where things get strange. Even though light is made of these discrete particles, it also behaves like a wave. Imagine dropping a pebble into a still pond. You see ripples or waves spreading out from the center. Light does the same thing. It can spread out, bend around corners, and even interfere with itself, creating patterns of light and dark, just like water waves can create high and low points. Section 4. An endless journey. Light's immortal voyage. Once a photon is created, what happens to it? How long does it last? In the vast, near-perfect vacuum of space, a photon is essentially immortal. It doesn't age, it doesn't decay, it doesn't run out of gas. Once launched from a distant star or galaxy, a photon will travel in a perfectly straight line forever, or until it runs into something. It is a tireless messenger. It can cross billions of light years unchanged, carrying energy and color from its birthplace to its final destination. The universe is filled with ancient photons, a ghostly sea from long-ago cosmic events. The journey ends only when it is absorbed. What does that mean? It physically runs into an object, an atom, a molecule, a planet, or your eyeball, and transfers all its energy to that object. The photon ceases to exist then. Its energy is transformed, not lost. Section 5. Cosmic yardsticks. Measuring the universe with light. Because light travels at a finite, constant speed, it becomes the ultimate measuring tool for the cosmos. Its speed, about 186,000 miles per second, 300,000 kilometers per second. Incredibly fast by our standards, but on the scale of the universe, it's quite manageable. This gives us a fantastic way to measure immense distances. We use a unit called a light year, which is simply the distance a photon travels in 1 year. It's not a measure of time, but of distance. 1 light year is about 5.88 trillion miles, 9.46 trillion kilometers.